Good day everyone, welcome back to another Prism Caribbean video. I am your tutor, Jordan Jaffa, and today we will be going through sets. Now sets would not be appearing in the paper 2 examination of the CSEC math. It will be in the paper 1 section, right? And sets is a very simple concept, often confused because small details are missed, which of course we will go through today. So it must be noted that the notation used in sets must be clearly understood before questions are practiced. Now today in particular we will only be going through one question. However, in videos to come again, we'll go through a bit more questions. But with regards to the paper 1, there would be usually one or two standard ways which I will show you in which how the questions will come, which I put in one question in particular to not confuse anything. But sets is a very important topic to still learn in math. So let's get down with the notation. So before we get there, let me just go through this here. So today we'll be going through explain the concepts related to sets, represent a set in various forms, list subsets of a given set, determine elements in intersections and unions and complements of sets, describe relationships among sets using set notation and symbols, which we'll go through now, draw Venn diagrams to represent relationships among sets, and use Venn diagrams to represent the relationship among sets, which we will go through as well. So now, with regards to notation, so this notation here means it's an element of. So that means 2 is an element of. This symbol here, which looks like an E with a strike through it, means it's not an element of. For example, 2 is not an element of. This symbol here means union of the set, which we can see here 1, 2, 3 is a union of this, 1, 2, 3 and 3, 4, 8. The union between both sets is 1, 2, 3, 4 and 8. What union basically is a combination of all the numbers used. So 1, 2, 3 and 4 and 8 were used, and it is written here in the set form. This symbol here means intersection. So we have set 1 and set 2 intersecting. So what we will find is the common variable. So 1, 2, 3 and 3, 4, 8, we can easily see that 3 is the common variable in both sets. So the intersection will be 3. This symbol here means subset of a set. So 1, 2, 3 is a subset of the set 1, 2, 3, 4, 8, which means that 1, 2, 3 exists inside the other set, which is 1, 2, 3, 4, and 8. This symbol here means superset of set, which we'll show here as 1, 2, 3, 4, 8 is a superset of 1, 2, 3. Right? Which can also mean that 1, 2, 3 already exists in this set here. So it is related by this smaller set as well. This symbol here means not a subset of the set, which means 10, 20, and 30 is not related to 1, 2, 4, and 8. There is no common variables. Both these symbols here denotes an empty set, meaning there is no variables, numbers, even letters sometimes they bring that can go into the sets. So they will say empty set, right? So let's look into this note here. Note a complement, which is this symbol here with the A and apostrophe. Complement means all the elements in the universal set which is not A, right? Let me just fix that back. Which is not A. Oh, change the color. Which is not A. So what this basically means is that, let's say A is a member. A is a member of even numbers. Okay, A, this is an A, is a member of even numbers. Therefore, A complement, okay, this is too thick when I'm writing. So, therefore, A complement will be a member of the opposite, which is odd. Or sometimes, to put it in a better example or better way, A complement will just be a member of a set with no even numbers. Because we can also face scenarios where 0 is also present, and we know 0 is neither odd nor even, you know? So moving on. Yes. Finite set is is possible to count, and it is possible to name all the elements in the set. Which means, okay, let's say we have A is a member of even numbers up to 12. That will be a finite set because we have, or we know, particular numbers which will go into that set, right? Infinite set is not possible to count, and the set is never complete. So this will be like, yeah. So this will be like B is a member of odd numbers, right? Now for the odd numbers, we don't know where the set ends. It can go up to infinity because we don't have an end to it. So this will be an infinite set, right? The null set contains no elements, which we've seen here already. These two symbols denote empty sets. The universal set is the set from which all elements are taken. The number of subsets, S is equal to 2 to the power of n. A common multiple choice question will be asking you to determine the number of subsets based on the number of elements in a set. So let's say set C is equal to 2, 3, 2, 4, 5, and we have to determine the number of subsets. So the number of subsets is equal to 2, and we see here n is equal to 3. So the number of subsets will be 2 to the power of 3, and as you said previously, complement is equal to A complement, or simply just a letter complement, right? It doesn't necessarily have to be A. So let's move on to our first question. Right. So, question 1. X is equal to prime numbers less than 20 and y is equal to odd numbers less than 20. So we know x is equal to prime numbers less than 20, which will be 2, 3, 5, 7, 11, 13, 17, and 19. And we know y is a member of sets with odd numbers less than 18. Right? Y contains, I should say, odd numbers less than 18. So to start off, we will have 1, 3, 5, 7, 9, 11, 13, 15, and 17. What we can instantly see from this is that both sets contain common numbers, or at least some common numbers. We can see both contain 3, so we can highlight that both contain 5, both contain 7, both contain 11, both contain 13, and we can see the last number is 17. Right, I should do that one a bit better. Okay, that'll run into some issues. So we know this is 17, right? So the first question asks us to draw a Venn diagram to represent the information given above. Now note, no need to worry. In the exam, for the paper 2s, as of the last syllabus produced, they won't ask you a question in sets. Sets only appears in paper 1s. And of course, they will draw the Venn diagram. So just an illustration of how the Venn diagram looks. It looks like this, where the same values, well, the intersection goes here, right? And we have the first set and second set. So if we want to find out the elements in set, let's call this set A and let's call this set B. We want to find out the elements in set A. It will be whatever is contained in this circle, including the intersection, right? Let's say you want to find the elements contained in set B. We want set B now. That will be whatever is contained in this circle. Well, I haven't drawn that properly, but you get the idea. It's everything that is contained in B, including the intersection. I hope you understood that. We'll be going through some examples on this now, so no need to worry if you didn't get that. So moving on to our first example again, we see the common numbers, or well, the intersection. We already highlighted the common numbers that are in both, right? So moving on to the part A, draw a Venn diagram to represent the information given above. Right? So, right, let me just select a different color there. Right, so drawing the Venn diagram now. Oh, I should draw that a bit different area, so as to not obstruct the view. Right. So for part A, we are going to draw the Venn diagram. Right? So we have we have the circle or the set for X, and we have the set for Y. I'm going to just show this a little bit bigger than how the illustration was, because we need to fill in the intersection. We have set X and set Y. Right? So let's fill. So whatever we have in green, we are going to put it in the intersection. Right? This is the intersection. Right? So the intersection will contain the numbers 3, 5, 7, 11, 13, and 17. Right? Now for set X by itself, meaning excluding these numbers, let me just fix this. 13. Okay, that. Right. Sorry, that was a 3. Right. So now we want to fill in for set X. Right? We know set X starts with 2. So we have 2. Okay, that's big as well. Sorry about that. Yeah. We know set X starts with 2. right? So we have the 2 here. We also know it contains 3 here, 5, 7, 11, 13, and 17, but we already have it in the intersection. Remember, the intersection is what is common in both sets, right? And the only number remaining is 19, so we simply put 19 here. Now for set y, it starts off with 1, right? And it also contains 3, 5, 7, 11, 13, and 17, just like set x. However, the number 9 still remains, so we put 9, and we put 15, right? So that's it for the Venn diagram. Sometimes in your questions, they may bring a universal set, and this may be a range of numbers, let's say in this case from 1 to 25, and then they will have set x is the prime numbers less than 20, and set y is the prime number, odd numbers less than 18. In this case, you would put the remaining numbers, that is, those that are in the universal set, outside. But whatever they tell you to put in the sets for x and y, that is, you put it in the circles. So now for part B, they want the x intersect y, or the numbers that are in the x intersect y. Well, we have it here already. Let me just change the color. We have the numbers for x intersect y is equal to the numbers that are in here, or you can use the numbers that are circled, it's the same numbers. 3, 5, 7, 11, 13, and 17. Right? So this is part B. Of course, this is part A. Now for part C, okay, yes. So now for part C, they want x intersect y complement, meaning in simple English terms, they want x but not y. Remember, y will be this whole entire circle including the intersection, and x will be the entire circle including the intersection. But if we eliminate y, we can imagine we're drawing some lines here to hide y, right? It will only lead us to 2 and 19. You can use your hand and cover the entire circle for y, and it will lead us to just 2 and 19, right? So that means x intersect y complement is equal to 2 and 19. Now for part D, they want y intersect x complement. So now for this, simply just take your hand, or in the exam you can even shade it because it's on the multiple choice paper. They want y intersect x. Yes, they want y intersect x complement. The x is a complement, which means you remove whatever is in the x. So that will mean you just cover this, including the intersection, because remember these numbers form x and y. But we don't want the x. So the only numbers that remain are 1, 9, and 15. Right. So yes. So y intersect x complement is equal to 1. Hold on, let me just fix this here. Right. So y intersect x complement is equal to 1, 9, and 15. And so for part E now, the last part, we want x union y. Remember what union was. It means all the variables inside the set. Right? So we're basically going to write down the variables here, and whatever was not in the x set, we will that is in y, of course, we will include it. So x union y is equal to, This is going to be a long one. So we just get some more space. Right. So that will mean 2. We basically start off by writing all the numbers for x, and then we can see what was missing for y. Now you don't have to go in ascending order, it's up to you. Remember, your exam will be for the sets question in the multiple choice, so it's less hectic on you. So we have 2, 3, 5, 7, 11, 13, 17, and 19 all existing in the x set. Now for y, we already know we have the 3, 5, 7, 11, 13, and 17 written out here. So the only ones that are remaining are 1, 9, and 15. So we write on that here. 1, 9, and 15. And we close off the set, and that's it. Remember, the brackets are like this when you're writing these sets. It's a little bit hard on me to write it online, but that's how it is. Right? Now back to some basics. This picture here must be learned off. It must be learned off because in the exam they can ask you for these in the multiple choice. And sets is a very basic concept. It's very easy. It can be very easily misunderstood, or you can be easily lost if you don't learn the basics of it. And to just go it over one more time, these notations here are very important, and then you can start to answer questions there, which we just looked at. Remember, x intersect y are the numbers that are common in both x and y, right? X intersect y complement are the numbers that are basically in x but are not in y. And remember, since they have numbers that overlap each other, you have to ignore those numbers as well. Same goes for D, and for E, they're simply asking what numbers exist in both x and y. And that's it for today. This is Sets. I am your tutor, Jordan Jaffa, for Prism Caribbean. This has been a wonderful session with Sets, and I look forward to see you in my next video.